Hello everyone, let's proceed with solving circuit diagrams using Kirchhoff's laws. We have this example, solve for I in the circuit. What's the first step? We need to assume current direction in each resistor. So we have assumed that for the 2 ohm, let's assume that the current is pointing to the right. For the 1 ohm resistor, let's assume that the current is passing with direction to the left. Next step is to form or choose the loop. We have this loop X, as what I said, let's make it a default. It's clockwise, and then we have this loop Y. Its direction is also clockwise. And then we have this, let's name this node as node A. First, form the KVL equation at loop X. So it passes through first this 120 voltage source, as you can see, or loop X, which is pointing upward, enters the negative, then leaves the positive. That's why KVL at loop X, we have this positive 120. And then next, it passes through this 2 ohm resistor. Our loop X is in the same direction with I1. Therefore, that is a negative IR drop, minus 2 I1. And then it passes through this 10 ohm resistor, and current I, which is pointing downward, is in the same direction with your loop X with regards to this resistor. That's why it would still be a negative IR drop. That minus 10I equals 0. Simplifying the equation, we have I1 plus 5I equals 60. This is our equation 1. Now let's form the KVL equation for loop Y. So as seen from the equation, let's start with this 100 voltage source. So as you can see, our loop Y enters the positive, then leaves the negative. That would be a negative 100. Then it will pass through this 10 ohm resistor. Then as you can see, our loop Y, with regards to the 10 ohm, is pointing upward, but our current I is pointing upward. Our loop Y is pointing upward, while our current I is pointing downward. That is of opposite sign. Therefore, that will be a positive 10I or positive IR drop. Then it passes through this 1 ohm resistor. Loop Y is to the right, but our I2 is to the left. It is of opposite direction. That would be a positive IR drop. So positive 1 I2 was 0. Simplifying the circuit diagram, that would be I2 plus 10I equals 100. So how many unknowns do we have? We have I1, I, and I2. We have 3 unknowns. For our third equation, let's just do a KCL at node A. What's KCL? Current entering equals current leaving. Our current entering is I1 and I2. So I1 plus I2 equals current leaving I. Simplifying again, I1 plus I2 minus I equals 0. This will be our equation 3. Using your calculator, simultaneous equations, 3 unknowns, I1, I2, and I, it can directly be solved. Or the unknowns can directly be solved, where I1 equals 10 amperes, I2 equals 0 amperes, and I, which is the unknown for this problem, is equal to 10 amperes. So thank you again for listening. Have a good day.